normal distribution curve. So normally to 10 marks questions, 10 to 15 marks question asked in the examination, weighted examination. So last year on this method, 14 marks question has been asked. So what do you mean by normal distribution curve? So normal distribution curve or graph is based on two factors, mean and standard deviation. The mean value will give center of the curve and standard deviation will give height and width of the curve. So this normal distribution can be transferred into standard normal distribution by formula by using z x minus mu by sigma. What is x? X is the value of original normal distribution. Mu is a mean of original normal distribution, and sigma standard deviation of original normal distribution. So we have some property of probability. So probability of x greater than n is equal to 0.5 minus c. Probability of x less than n is also equal to 0.5 minus c. And probability between of x between a and b is equal to c1 plus c2. This c value are called as a confidence values, which will obtain from the alpha, that is significance value, which will be given in the questions. So these three equations and these equations are very important when you solve that or when you want to have a normal distribution table. So keep in mind first equation for z and these equations for probability calculations. So normally questions on this method ask, so based on this probabilities, how many workers are, how many students are having average marks, how many students have scored more than 80, more than 90, or how many workers work for a day, like this question will come in the examination. So these three questions totally used for that. Then apart from this, we will use normal distribution table, Z table for one tail test for using this method. So remember that, I'll make a note of that. Normal distribution table for one tail test. Okay, so now next we'll go to the next page. So let us have one example on this equations. So remember this equation, if you want, you can make a note. Next, one example, we'll see. There are 2000 applicants appeared in an interview. The distribution of marks is assumed to be normal. So as you observe here, the point is mentioned as normal. This is means normal distribution with mean 30 and standard deviation sigma 6.25. The question is, how many applicants are expected to get marks? Okay, this you observe here. Between 20 to 40, how many students will get marks? Next, less than 35, how many students are there? And above 50, how many students are there? So we will use these conditions here. So just observe here. Between 20 to 40 means this is the equation C1 and C2. Then less than 35, we can use x is less than n, that is 0.5 minus c. And greater than or above 50, again we can use same equation 0.5 minus c. So these c values will be depends on alpha. So now we'll go to the solution of this example. So first of all, what is given in the question? Number of samples or applicants are 2000, that is taken as n. Then mean is given 30, taken as 30. Then standard deviation is given as 6.25. Now, first question is applicant expected to get marks between 20 to 40. So just observe here 20 to 40. Now, what we need to do in this method is, so let us assume the range of marks between 20 to 40. First of all, let us put x is equal to 20 in z equation and calculate what is z value. Then second value, again put x is equal to 40, x is equal to 40, again calculate the z value. So if you observe that when you put x is equal to 20, so mu already we know 30 and sigma already we know 6.25. So if you calculate, you will get minus 1.6. Similarly, if you use x is equal to 40, the value of xz is equal to 1.6. So here it is negative and it is positive. Now, so by using this z value, we need to calculate the area or c values. So you all familiar with the z table, that is normal distribution table. Now we'll take the one tail test. Now here, since significance is not given, let us assume alpha equal to 5%. So from standard normal distribution table, so a normal curve, what we can see, so Z 1.6, the C value, what is C value? And for Z 1 minus 1.6. So when you take one tail test, so this is on the positive side, this is on the negative side, if you just observe here. So this areas will give you the values of C. So probability of a student scoring 20 to 40 marks will be obtained by multiplying the probability which is obtained by C value with number of students. Okay, there are 2000 students. So based on this probability, so the probability which come in this area will give number of students score between 40 to 20 or 20 to 40. Now, how to see the value of C from one tail test? It is depends on the value of Z. So if you observe that, if you calculate Z is equal to 1.6. Now I'll go to the graph or normal distribution table. Just observe here, all of you. So if you clearly observe this normal distribution table, so for 1.6, Z value 1.6, so it is 0.4452. So if you just observe here, I'm putting a anchor here. So 0.4452, that is a Z value. This is a one tail standard normal curve. Okay. So for 1.6, it is 0.4452. Okay, make a note of this. So how to see that? Z value 1.6 and see the first value. Suppose Z value is different, we have to see Z value by using upper and lower limits. Okay, now I'll go back. So what is the answer we got here is, for this case, so the value of C is 0.4452. Since we have two Z's, minus 1.6 and plus 1.6, so there will be two values. This is called C1 and C2. Okay, so this side one you can say positive side, and this side you can say negative side. So there will be two things. So the total probability will be taken by calculating the area. So what is the area of this one is C1 plus C2. Okay, that's why in the equation I've written here, just observe here, C1 plus C2 when you are using in between. Okay, so just observe here. So we'll go back. So this is C1 value, this is C2 values. Okay, this is the way you need to calculate the C values. Okay, so now P is equal to probability of that test student scoring 20 to 40 marks will be given by area of Z. So I hope this is clear to you. Next, I'll go to the next page. Now, so this is our C1 and C2. So the total probability is 0.8904. Don't think about the positive and negative signs. So you need to take C1 and C2, or both the C's you need to add. So once you got the probability, the number of applicants with expectation of mark between 20 to 40 will be obtained by multiplying number of students with probability. So if you multiply 2000 with this probability, you will be able to know how many students are score marks between 20 to 40. Okay, so this is the way this normal distribution method is used. Next, second point. What is the second question is expectation of marks less than 35. So less than 35 means only one parameter is there. So put x is equal to 35 in Z equation. Mu already we know, sigma already we know. Now you can calculate Z. Again, when you found Z, so Z is equal to 0.76, we need to calculate the C value. So again, I will go back to the table, just observe here. So what we have, Z is equal to 0.76. So when we have Z is equal to 0.76, I'll show you the table. So here, Z is equal to 0.7. We have 0.7 and 6 will be taken from the upper side. So if you observe here, so this is 0.7 plus 0.06, it will give 0.76. If you observe clearly, the value of 0.076, sorry, 0.76 is 0.2764. This is the column. So I'll just zoom it and show you. 0.2764. Okay. So now I'll go back to the next page. So just observe here. So I've written here for Z is equal to 0.76. The value of C is 0.2764. Now we have the equation when the value is less than or greater than. So x is less than 35. The question is expectation of marks less than 35. So probability of marks less than 35, we have the equation 0.5 minus C value. So subtract this value, so you'll get 0.2236. Now expectation of marks, the student who score less than 35 can be obtained by multiplying this probability with number of students. So when you multiply, you will get 447 students. Out of 2000 students, 447 students are scored less than 35. Now this is the second bit. Now come to the third bit. Expectation of marks above 50. So when Px is greater than 50, again 0.5 minus C. Now put x is equal to 50 and find out the value of z. So z is equal to 30.2. From normal curve, when you see again, go back. So the C value will be 0.4993. So again, I'll show you so that you should not have any confusion while using the table. So 3 point, what we got x value of. So here, so the value of z is 3.2. Now I'll go back chart. So 3.2. So again, starting we will take 0.4993. Now I'll come back. So 0.4993. This also. So C value is 0.4993 for z equal to 3.2. So now the probability of x value or greater than 50 is again by using division 0.5 minus 0.4993. So P will got. Now expectation of marks above 50 can be obtained by multiplying this probability with the number of students. So if you multiply, you'll get the answer of 1.4. So nearly one student only got more than 150. So this completes the question. I hope it is clear to all. So this is a one example. Now I'm taking a one exam question. So previous year, academic year, for 14 marks, this question has been asked. So just see how many bits? 1, 2, 3, 4, 5, 6. Okay. So similar question with different varieties. Now, the daily wages of 1,000 workmen are normally distributed around a mean of 70. So see, mean is given and standard deviation is given. So how many workers? N equal to 1,000. Estimate the number of workers whose daily wages will be. So he's asking, so average wage is 70. Now he's asking, what is the worker daily wages? How many workers having a daily wages from 70 to 72? Second point, 69 to 72. Third point, more than 75. Fourth point, less than 63. Fifth point, more than 80. Also estimate the lowest daily wage of the 100 highest paid workers. This is very important. So this we have covered in the previous example. So this is the extra point. Okay. Now we'll solve here. Okay. All of you just make a note of this question. Let's just go for the next solution. Now, what is given in the question? So number of observation is 70. Mean is number of observation is 1,000. Mean is 70, and sigma equal to 5. Now estimate the number of workers' daily wages when it between 70 to 72. Again, we will use variety because this is a range. So put x is equal to 70. Now calculate z. So when you put x is equal to 70, so since use 70, the value will be 0. Now when you put x is equal to 72, so the value will be 2 by 5, that is 0.4. Now for z is equal to 0, c1 is equal to 0 because here range will have up to c values. So if you observe the table for z is equal to 0, c value will be 0. Now for z is equal to 0.4, c value, I'll show you. This observe all of. I'll go back to the table. Okay, this observe you. C is equal to 0.4, it is 0.1154. Okay, so here 0.1154. 0.1154. So now, so probability of x marks between 70 to 72 is adding C1 and C2. When you add this, you will get 1.1154. Now question is, how many workers having a wages between 70 to 72? Multiply with this with the number of workers, you will get how many workers are getting around 70 to 72 rupees per day. So when you calculate 100 into this, it will be 155.4. So nearly it is equal to 151. Okay, so this completes the first page. Okay, right now let's go to the second page. between 69 to 70. Similarly, you have to do x is equal to 69, put x is equal to 69, you'll get 0.2, z equal to 0.2. If you see the table, C1 will be 0.0793. At x is equal to 72, z is equal to zero point 0.4. Already we know zero point 0.4, so 0.115. So the probability of x between 69 to 72 is C1 plus C2. Add these two values. So you'll get probability as of between this range is 0.2347. Now wages. So wages can be obtained by multiplying this with the number of workers. So there are 1,000 workers. So multiply it. So you will get around 235. So this is a second. Now third bit. So what is asked? Less than rupees 75. Now put x is equal to 7. So only one range. So x is equal to 75. You will get z is equal to 1. So when you see the table for z is equal to 1, c value is 0.3413. Okay. Now we have the equation for probability of x less than 75 is equal to 0.5 minus c. So c value we know. Put it, you will get this one. Now multiply with the number of workers, you will get the number of labors which wages which is less than 75. So it is around 159. Next, fifth point, more than 80. So put x is equal to 80, find z value, c value, and then again use equation p x is greater than 80 is equal to 0.5 minus c. So 0.228. So if you subtract this value from here, you will. Now number of workers will be multiplying this probability with number of workers. So you'll get 23. So these are the answers. So similar answers for whatever we solved in the previous example. Now last also. So what is the last answer is to estimate lowest daily wages of 100 highest paid workers. So if you observe that there are 1,000 workers, so out of that 100 highest paid worker value need to calculate. So 100 out of 1,000 worker, the probability of highest worker is P is equal to 0.1. So slightly different here. Instead of calculating C, now we need to calculate. So instead of measuring T, measuring or calculating P, here what we will do, we will use this equation P is equal to 0.5 minus C. So if you rearrange, you will get C is equal to 0.5 minus P. So from this, we'll get the value of C. Are you getting a point? So the C value will be calculated by using this one. Now you need to check reversely here. So what is the question is estimate the lowest daily wages of 100 highest paid customers. So probability you will calculate by 100 by 1000. So from this you will calculate C. Now you need to find out where is 0.4. So for 0.4 you need to calculate what is the Z value. So if you check the table, it will give 1.28. So what I will do, I'll show you the table so you can check it. So 0.4, you need to find out the value as 0.4 in a table. So just observe here, I'm going to the one tail table. So here, just you observe here where you are getting 0.4. Now see. So here 0.40 just crossing. So 1.2 just you observe 0.38, 0.38, 0.39. So maximum I can go up to 0.3997. After that it will be 0.40. It is going beyond 0.40. So what I can do, I can take this value. This value gives Z as 1.2 plus 0.08. Just observe here 0.3997. So 1.2 plus 0.08. So I've taken it for this case. So just observe here 1.2 plus 0.008 is equal to 1.28. I hope this is clear. So first of all, you need to calculate p value when you have 100 out of 1000. So you have to find out probability of highest paid worker. Then from probability, you need to calculate C. Then after calculating C, from the table, one tail table of normal curve, you have to calculate Z. So after finding out the Z, again use Z equation. Now in this Z equation, we'll use to find out what is the X. X means what is the highest rupees paid to the highest person. So from this, if you observe here, so if you rearrange Z into sigma is equal to X minus mu. So this is equal to X is equal to mu plus Z into sigma 1.28 into 5 into 70. So you'll get 76. So this is implies that the richest 100 is rupees 76. So out of 1000 rupees, 100 people will get rupees 76. So this complete your question. So slightly tricky one. So first of all, you need to calculate probability, then C value, then you have to calculate Z, then finally you need to calculate X. So the question is estimate the lowest daily wage of 100 highest paid workers. So among 100 highest paid worker, the lowest value is 0.76 rupees. So this complete your normal distribution method. So thank you. Any queries, any question, you can put comment. Okay, please share the videos, share with your friends, and practice and do well in the examination. Thank you.